Alright everybody, I hope I'm live right now. First of all, I have to be sure about that. So let me just actually turn it on and see whether I'm audible or not. So hello, can you hear me? I think I'm not really speaking here. I mean, at least my voice is, I'm not really audible here on live. Alright everybody, I hope I'm live. I'm actually audible. Okay, then without any further delay, let's simply get going. And here, first of all, we are gonna be going through the thing that I left earlier. So we mainly wanted to discuss, we had to go through this synchronous and asynchronous thing. And what I think before even that synchronously means everything runs so line by line, and first of all that needs to be done, then only the another thing can be done. When it comes to asynchronous, so in the asynchronous, that keeps happening. I mean, suppose if something is asynchronous, so that will happen in the background and then the process will keep going on. I'm not sure, but I hope this is something like that, but let's see. Synchronous process runs sequentially where each task must finish before the next begins, causing potential waiting blocking. Asynchronous processes allow multiple tasks to run in parallel, and that's what I was just simply saying. So when it comes to asynchronous, so things can actually run parallel sort of in the background. Okay, let's name it parallel. So things can actually run parallel, letting the system continue other work while waiting for long running tasks to complete, which increases the responsiveness. So ultimately what happens, that if there is a long a running task, so that will keep happening parallelly, that will keep getting processed parallelly and parallel whatever. Okay, so parallelly, how to pronounce this? Parallelly. Pronunciation of parallel is fine. Parallel. Pronunciation of parallel,
Parallel.
parallel, parallel. Okay, that's great. Parallel. So parallel and parallelly. That's crazy. Parallelly. That's wrong actually. Parallelly. Parallelly. Just like this is the right spelling. So that's actually gonna be parallelly, right? Parallelly. Yeah, that's what I want. So why am I not getting it? By the way, this is actually parallelly. 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 Yeah, that's fine. So ultimately, the interesting one is this only, parallel and
Parallel.
parallel. And how about in India?
Parallel.
Parallelly. Yeah, that's fine. Okay, let's forget about this. I was just simply practicing this right now. So ultimately, what happens that it lets await asynchronous lets the process run in the in the background parallelly, and meanwhile your remaining code can just simply run. So this is how it just simply happens, and whenever the result is response is returned, you just simply get that. So this is how it just simply goes on, and okay, luckily we've gone through this as well. So we were mainly here in this particular section, and we were talking about this. So ultimately the same thing is happening over here. So there are two ways, synchronous and asynchronous. Synchronous in the sense when you do not use Kafka, that simply means suppose there is a notification service, so that is just simply sending a request to, for sending a notification, and then you have to simply kind of get that notification sent. So this is synchronous communication, because first of all it will send, then you will resolve that, and then again ultimately messaging server 1 will simply send the request, messaging server 2 will send the notification, and then simply send back the response. And when it comes to async communication, so Kafka is gonna be used over there, and as Kafka is used, so what will happen, there's gonna be publisher and there's gonna be a subscriber, ultimately workers. So you are a publisher will just simply push the request in a queue, and workers or subscriber, that is gonna be just simply pulling them one by one and resolving them, just simply getting the job done, whatever is supposed to be done. Okay, so this is what this particular diagram actually represents over here. and we have sort of gone through that. So ultimately we were talking about messaging queue and PubSub model and all. So this thing is done, what this PubSub model actually does, and what does it mean actually. So uh, the the question comes, why we actually need to use Kafka over here, because the thing is simple. Messaging server one may send a lot of services. Ultimately it may have high throughput. How high throughput in the sense, it may get a lot of requests at the same time. So it can the messaging server, simply put, server 1 is actually able to handle a lot of requests at the same time. Server 2, messaging server 2 is not able to handle a lot of requests. That simply means throughput is lesser, and hence if there's a lot of pressure on server 2, it will just simply crash and it will be down. Okay, hence we need to introduce Kafka in between. So HLD, throughput, OPS, operations per second. So ultimately when it comes to throughput, so in HLD throughput is nothing but the operations per second. That simply means in a second how many requests you are actually able to handle. If more request comes than that, more requests hit than that, in at that time your server is gonna crash, because of course you will not be able to handle that. So this is what we just simply discussed. And when it comes to throughput, so in services, in companies like Ola, Uber or Rapido, throughput is really high. Throughput is really high, simply said, because look, whenever you just simply book on Ola, so what happens that you need to get the current location of the Ola van or bike, wherever that is right now. So to get the current location, what happens that every second uh, ultimately the driver, the Ola driver's GPS, so whatever device, from the Ola driver side, from the Ola vehicle side, a signal will be sent to the Ola server in every 1 second or something, because you need to know about the current location, right? So a request will be sent from ultimately Ola driver side to the Ola server, and Ola server will just simply send it back to the client. So it will be like bi-directional over here. Simply said, what will happen? Ola driver will just simply, from Ola driver side, the current location will be sent to the Ola server, and then it will be sent back to the client. So in this way, ultimately, in every second, one request needs to be sent to the Ola server, and this will just simply keep happening until your, I mean, your Ola drive, Ola vehicle. Now that is actually called Ola vehicle. So Ola vehicle, ultimately bike or van, actually arrives. So this is the first thing. But here we just simply assumed one user. Similarly, in big cities or metro cities and all, there can be lakhs, thousands and lakhs of users. Hence, the traffic on this particular Ola server is gonna be too much. So, what could be the better approach over here? And for that thing, we are gonna be using Kafka over here, if I'm not wrong. So ultimately, what will happen? It will just simply send the request to the Ola server, but in between that's gonna be Kafka. So Kafka will receive the request, and Kafka will have lots of workers. They will be just simply resolving it and just simply getting the job done. But let's see how it's gonna be going on. We can even do back of the envelope calculation, BOE calculation over here. So in Delhi, cities like Delhi and all, there can be 1 lakh driver. So ultimately, 1 lakh requests are sent 1 lakh requests are sent per second. So if we just simply try to add a value to DB, fair calculation, SQL, NoSQL, Cassandra, Mongo, DB will have very high load. That's right. Messages ultimately over here, both the kind of databases can be used, MongoDB and Cassandra. Uh, these are the NoSQL databases, and SQL database you can also use. Depends which can be the best suitable one here. So if I'm actually using what do I actually need to say? First of all, let's simply check this thing out. Messages queues, there's gonna be Kafka. How Kafka will resolve the problem? So it will just, GPS will just simply send the driver vehicle will share a live location. 1 lakh requests are gonna be going to the Ola. Now what will happen? Ola needs to send the current location to the client. So Ola will just simply send the request to Kafka. Kafka will have a worker that will just simply get a request from the ultimately queue in every 1 minute, and there are gonna be consumers. They are gonna be just simply putting the data in the database, and the client is also gonna be informed. Now this can be SQL, this can be no SQL, depending on what kind of data you are actually storing. So it's pretty simple. A GPS will just simply send the request to ultimately Ola server, that is gonna be sort of a producer, because you need to save all these entries in the database. Hence you actually need to kind of, and the question is, why do you need to save these entries in the database? I mean, to just know more about your customers and all. And the other thing is that if the suppose the client logs in after some time, so as the entries are in the database, the client will be able to see the whole route, exactly how the rider actually, I mean which way the rider actually came. So that's good. I mean, it's good to just simply save the entries in the database, and then we are going to be simply notifying the client as well. So 1 single second every data GB that exists will not have such high throughput. That is right. Ultimately the database that I have, it is not possible that, I mean, it's not like there are going to be just 1 lakh requests. There can be requests in crores as well if that application is being used the most. Hence, the database will not have that much throughput. That is why we will have to use a service called Kafka. That is a messaging queue that have very high throughput. Workers will do bulk upload on DB. Bulk upload in the sense, workers are not going to be just simply pushing the data to the database in every second. Rather, workers will do it in some intervals, and that two workers are gonna be just simply pushing the data in bulk. So suppose workers will get the data of a minute, and then they'll wait for a minute, and after that they'll just simply push the data. So ultimately they are gonna be just simply saving the data in the database in every 1 minute, not in every 1 second. So this is how it's gonna be going on. Job of web server: take the request from the client, process the request, put the data in the DB. So ultimately, if there's any web server that is going to be taking the request from the client, process the request, and put the data in the DB. DBs are completely slower, latency will be high. I mean, there are B plus trees and B trees. Let's know more about it exactly, because I have no idea about B plus trees and B trees, so I will be knowing about it. It was sort of mentioned in the class, so why not know it? And apart from this particular thing, pretty much simple stuff. So yeah, the next question is gonna be, tell me about B plus trees and B trees. Okay, so let's see what exactly they are. And the another thing is that HLD is all about high level stuff. So ultimately, on a high level, you just know how the things work. But if you actually know the if you actually want to know the real implementation, you need to know about LLD, low level system, low level LLD design. And for that particular thing, you need to know DSA. So the thing is that I cannot really start learning low level design until unless I actually know DSA. So the next goal is gonna be learning about DSA and then switching to LLD, because this is just the theory, right? Nothing happens with the theory until unless you actually implement that. So that is why it's good to know the theory. I will keep revising that too, but I do need to know about LLD to just simply implement the things in practical applications. Hence, I need to cover DSA too. Okay, by the way, let's understand B trees and B plus trees in simple and clear way. What is a B tree? So, a B tree is a self-balancing search tree where each node can have multiple keys, not just like one binary key. So, each node can have multiple keys. Okay, each node can have more than 2 children. That's fine. Okay, data is stored inside all nodes, both internal and leaf. Okay, so ultimately it's gonna be sort of like this. I think I do not have good network connection here, but never mind. Does it mean I'm facing a network issue? Not really. Oh yeah, of course. Okay, never mind. Can't really do anything. So ultimately, this is how the tree is gonna look like. Not like this actually. Probably like this. So there's gonna be root. There are gonna be internal. There are gonna be leaves. Alrighty. It turns out I still have to know more about it, but this much information is good enough. Nodes are sorted. Okay, nodes are sorted. All leaves are at the same level. Balance the tree. A node with k keys has k plus 1 children. K plus 1 children. K. A node with k keys has k plus 1 children. Efficient for disk storage used in databases. Okay, that's good. It is used. And I think this is the part of DSA, if I'm not wrong. A node might look like 10, 20, 30 left of 10 values. Okay, it's not really gonna go in. I'm not really gonna understand even the example, because again this is completely a new concept for me. But okay, never mind, we'll go through DSA part. Search, insert, delete, What is B plus T? A B plus T is an improved version of B tree. The main idea: all HL data is stored only in leaf nodes. Internal nodes store only key for navigation. That is good. Key leaves. Okay, that's great. Is this a part of DSA? Yes, B trees are absolutely part of DSA data structures and algorithm where they fit trees, advanced structures, binary tree, binary search. This B trees and B plus trees are considered advanced real world trees. Okay, that's fine. Why they are important in DSA real world? Okay, that's fine. That simply means this is the right time to just simply get into this DSA stuff, and I have to just simply complete it as soon as possible so that I can just simply start learning about LLD stuff. So at least 3 months needs to be given to DSA, or even as less as possible, and then I have to switch to LLD. Time is less. I have just 6 months. That's it. Okay, let's continue. So Kafka in depth, why it is useful. This is okay, producers and async communication notification. So ultimately what happens that producer will keep pushing the request in the Kafka queue, and then consumer will just simply keep consuming them on its at its own pace. In depth, there are a few things in Kafka that we need to actually worry about. This has been the overall architecture, but there are more things inside this. So cluster is nothing but the combination of many brokers. Now what is a broker? Broker is nothing but combination of topics, queues, topics, partitions, queues and all. Now what is a topic? Topic is nothing but the group of some partitions. There can be multiple topics. They may belong to different services, and those topics will contain the partition. Now what is the partition? Partition is nothing but a queue. Offset, the way array has indexes, the same way partition has the offsets. So there can be offset 0, offset 1, offset 2. It will just simply keep going on. Zookeeper or craft, they are just simply responsible for storing the information about your queues, exactly queues and workers actually, how many, and they'll store information how many requests have been resolved. So in the queue there are going to be many requests, how many requests the worker has actually resolved. All this information is actually going to be saved inside Zookeeper or craft. Consumer, again this is simply consumer. They can be called worker as well. They are just simply consuming. Ultimately they will get the request from the they will take the request from the queue and just simply process that. Consumer group is nothing but a group of consumers. Again there is some difference in them. Consumer, the main reason behind consumer and consumer group is that earlier we just simply used to have consumer. Now the problem was that two consumers could not connect it to the same partition. We will be just simply going through it, especially it is already mentioned below. But two consumers which belong to the same group cannot connect to the same partition. Hence we had to create consumer groups, and now two different consumers from two different two consumers from two different consumer groups can definitely connect to the same partition. We will be just simply going through it, and producer we already know it. So okay, let's simply go through this thing as well. So we have producer, we have a broker. This is a broker. Broker just simply contains everything. So it is sort of a Kafka server over here. So ultimately the environment, the server that simply runs everything. There are going to be different topics related to different services, and those topics will have different partitions. So this is the partition number first, this is the partition number second, and those partitions have different offsets. So offset 0, offset 1, offset 2, these are the offsets over here. Similarly there can be multiple topics, multiple partitions, multiple offsets, and they are going to be consumers. So ultimately what will happen, consumer will connect it to partition, specific partitions, and it will just simply start serving, as simple as that. Let's continue with this. So over here what exactly happens, that we send a request to the, again whenever we are sending a request, whenever a producer sends a request, so producer just simply sends all this information, like what should be the broker. First of all, again broker is decided because this is a server, so it's gonna be auto scaled and all. And apart from this particular thing, we will have to mention the name of the topic, which topic is gonna be used. Then we'll have to mention the name of the name of the partition as well, which partition is gonna be used, and we have to give it the value. On the basis of that thing, producer will just simply save the push the request in one of the queues, and once the request is actually pushed in one of the queues, consumer is gonna be just simply consuming them one after the other. Okay, so this is how it's just simply gonna be going on. And apart from this particular thing, okay, what I was just simply saying over here, that there can be multiple consumers, that's fine, and one consumer can connect to two different partitions that will work. Simulate the way this consumer 1 is connected to these two partitions, consumer 2 is connected to these, so that is possible. But one consumer and two consumers which belong to the same group cannot connect to one partition. That was the problem, hence we had to create consumer groups. So if I actually show you this thing, so if we have only one partition over here, just imagining right now, and we have two consumers that are in the same group, so it's not like if I try to connect both of them in the same partition with the same partition, that's gonna be problematic. So if number of partitions are less, then number of consumers, some consumers will remain idle ultimately. Yeah, okay, I started talking about something else is discussed over here, but okay, let's simply go through it. So if number of partitions are less, that simply means I have only one partition and I have two consumers, so no doubt few consumers are gonna be idle. Why? Because look, if there is only one partition and you have two consumers, so two consumers that belong to the same group cannot connect to the same partition, hence one of them is gonna be idle over here. One consumer can consume multiple partitions. One consumer can actually consume multiple partitions. Similarly, there could have been one more, there could have been one more. So this way, this could have been connected to, this could have been consuming multiple partitions, but two consumers cannot connect to the same. But one partition, just a minute. Ultimately, what's discussed over here? One partition can be consumed by only one consumer. So what it is actually saying, hello everybody, welcome back. The thing is that right now my network connection got disconnected, hence everything was paused. The live was not ended, it was actually paused, and now here I have resumed it again, and hopefully everything is gonna be fine. And let's simply start discussing the things. So we were just somewhere here, and we have already gone through all these things. I was just simply talking about that one partition can be consumed by only one consumer. It's not like one partition is actually being consumed by two consumers. This is possible only when they belong to two consumer groups. So that's what we've discussed over here. So this is the first thing. So consumer group is fairly new in Kafka. It has been recently introduced. So when it comes to if we want that same one partition should be consumed by multiple consumers, so those consumers should belong to different consumer groups. So this is the consumer group 1, for example. This is the second one. So two consumers from separate different consumer groups, they can just simply connect to the same partition, but it cannot happen in the same one. Okay. So why Kafka does all these things? Consumer group is fairly okay, because Kafka needs to handle two things. What are those two things? Kafka needs to handle ultimately messaging queue and PubSub model. PubSub model in the sense this publisher and subscriber model, and queues they just simply go with the FIFO, first in first out. This is the what I mean. There are many other ways as well. When it comes to the queues, so there are gonna be I think first in first out. So as the request come, they are just simply first request is just simply resolved first, and the second one is resolved second. And there's another thing that is called publisher and subscriber model. So here what do, you just simply publish, and there are workers that are just simply getting it done. So let's see exactly how it works. So when it comes to this, so there's one producer and there is one consumer, that is right, and it just simply sends the request to the queue, a consumer consumes it. And PubSub model, publisher subscriber model, suppose this is the channel publisher, and then there can be multiple. Ultimately at the end of the day, publisher or the producer will just simply keep sending the request or pushing the request to the queue, and now there can be multiple subscribers, ultimately multiple workers that may be consuming it, and hence this PubSub model was introduced. So okay, that's fine as well. And Kafka, LinkedIn, Zookeeper, that is fine, we have already gone through this. And if one in a consumer group one of the consumer dies, so another one just simply continue. And the question is that if one of the consumers dies, then what will happen? That is why we have zookeeper over here. So zookeeper will contain all the information. What kind of information? What is the consumer group? So the consumer group was one. What is the consumer that is currently being used? So second one, topic. What was the topic? Suppose this is 0 was the topic. Partition, offset, partition. What was the partition that was being used? So suppose 0. And partition, offset means how many, what was the offset of the partition? Suppose here it was 2, that simply means uh, these many. Before that all the partitions were just simply resolved, not all the requests of the previous offsets, they've been resolved, offsetted 2, and now you have to go forward from 2. So now you have to go to offset 3, you have to go to offset 4, and just simply get it done. Remaining things have already been resolved. So ultimately zookeeper just simply contains all the information. When it comes to the cluster, so cluster is nothing but the combination. So there can be multiple brokers, and you have to just simply make sure that they are scaled better, if I'm not wrong. So ultimately the combination of brokers, ultimately the environment that manages them in all, that is just simply called clusters. And lastly, then we have something called method, round robin method. So what happens in this particular round robin method, that if there are many partitions, right? So first of all, the first way is that if there are many partitions over here, so when the producer is actually sending the request, so ultimately that particular request needs to hit these partitions over here. There can be partition 1, 0, 1, 2, 3. I mean there can be multiple partitions here. Hence there are multiple partitions. So first of all, the simple thing is that you will have to mention the key, that is optional, that is just for your data and your request and all. Value, of course, that is needed. You will have to mention the topic in the sense in which topic this request needs to be first of all pushed. And the another thing is that what should be the partition in that. So suppose again this partition can actually be optional here. If the partition is optional, round robin method will be used. That simply means first of all the request will be pushed in this one, then this one, then this one. It will just keep following round robin method algorithm, and it will just simply get the job done. The second thing is that if a partition is actually given, like okay, this is the partition that should be used, so of course it's gonna be using that particular partition. Pretty simple. I mean it does make sense. And as for this round robin method, it will be just simply selecting them one after the other. Okay, pretty simple. And apart from this particular thing, there is something called dead letter queue. Dead letter queue in the sense, if there is a producer that simply pushed the queue, push the request in a queue, and the consumer will consume it. But if something went wrong, okay, some bugs occurred and that could not be resolved, in that case that particular request will be sent pushed to another queue, that is gonna be called a dead letter queue, and there are gonna be some retries mentioned. So that dead letter queue will just simply push it back to the main queue, and that will be retried 3 times or 4 times. It completely depends on your configuration. And once that is done, then that is it. If it is still failed, then of course that's gonna be dropped. And there is last thing, that is something called rabbit messaging queue. This is also one of the queues. So far we've mainly been discussing about Kafka and all, how Kafka works. Even in rabbit queue we have multiple queues. So there's gonna be queue number 0, there's gonna be queue number 1, and what happens, producer is just simply sending the queue, sending the request to the queue. And there is something called exchange in between. This exchange just simply keeps 2 things intact. First one is the this messaging key, so ultimately, and second one is the routing key. So whenever the producer just simply sends a request, it just simply goes via this exchange. It has 2 things. It has a messaging key, what is the key of the request that it actually got, and what is the routing key. So it knows where to forward this request. So queue number 0, queue number 1, or queue number 2. It just simply keeps these 2 things in mind and just simply get the job done. So ultimately it will have 2 keys. It will have the messaging key, ultimately the request key, that is the request that it has, it is getting the key of that. So it will be just simply recognizing the request based on that. And the second thing is the routing. So it will be just simply routing that particular request to a particular queue here. So this is how it just simply happens. Similarly, there can be multiple consumers here, and those consumers may be listening to different queues, and they may be just simply sending the data in some kind of database. So this is how it just simply goes on. Exchange, what is the use of this? So rules that decide message will go in which queue. So this is nothing but rules. It contains 2 things, messaging key and routing. We've already talked about it. There are few algorithms, sort of methods here. First of all is fan out broadcast. That simply means whenever you send a request, it will be broadcasted to all. This is one of the things. Direct exchange, match MK and RK, we have already talked about this. It already has uh, message key and routing key. On the basis of that thing, it just simply gets the pushing to the queues done. And lastly, we have topic exchange. Wildcards are allowed as well. Wildcards, in the sense of, it's gonna be something like this. So the routing key can be 1 2 3 in some fixed routing, as well as some routing with the wildcards. That simply means anything after queue can be here. And at the end of the day, when it comes to requeue mechanisms, ultimately Kafka uses a pull-based technique. Pull-based technique in the sense, it if it has to get something, it just simply makes a request. Rabbit messaging queue uses push-based technique. Just simply means it pushes from its own side. So these are the few things that we just simply discussed. I mean, it's pretty simple anyway. Alrighty, so we have talked about messaging queue and PubSub model. It's pretty simple when it comes to messaging queue. So there are clusters, then there are brokers, there are topics. I mean, these are different things that we need to know about. So if you are knowing about messaging queue and PubSub model and all, so you need to know about clusters, brokers. They are nothing but servers. Then topics, partitions, offsets, and apart from consumers, consumer group, and zookeeper, and all these things you actually need to be aware of. Okay, so this is how it just simply goes. We have sort of gone through this thing. So now we have to know more. Just this queue, we have already talked about it, so let me just simply get rid of it. Mainly we are discussing about caching over here. So we discussed intro, architecture, cap theorem, back of the envelope calculation, monolithic versus microservices, DB sharding, and load balancers. DB sharding in the sense, there are two ways to just simply scale the DB, and we talked about both. Ultimately, sharding the DB using the hash function and just getting the mode of that. And the second one is the consistent hashing. That is something that is used the most when it comes to load balancers. So there are two types of load balancers, static and dynamic, and there are algorithms on them. So they are used. So when it comes to algorithms, so there are like a round robin algorithm, there is a weighted round robin algorithm, and there is a IP hashing algorithm in static section. In dynamic section, we have list connection method, we have weighted list connection method, we have what else? We have list, we have weighted list, we have resource request, I mean request resource method, and lastly we have I mean there are some, you can just simply go through it. These are the at least the response time. On the basis of the response time as well, it is just simply forwarded. So these are some of the what algorithms that are actually used. Then we have rate limiting. Even in rate limiting, we have around 5 algorithms here. One of them is how it is bucket token bucket. If I'm not wrong, so bucket token or token bucket, leaky bucket. So yeah, we have token bucket, we have leaky bucket, we have fixed window counter, we have sliding window log, and we have sliding window counter, something like this. So these are the strategies that you need to be aware of. And there are some caching strategies. Ultimately, we discussed about caching briefly over here, and the main caching related stuff is gonna be discussed over here. Then we talked about designing the URL, shortener URL. So ultimately what happens whenever you are designing a shortener URL, so you are going to be making a request to the database, you are going to be making a request to the server. Now server needs to just simply create your URL, short URL. So the best way can be that you actually generate the short URL based on the ID of the database, because the ID is going to be different all the time, and hence when you are just simply passing it through the hash function, so you are going to be getting different different string, and that string is going to be used for the short URL. So this is going to be one of the things. The only challenge is that when you are using ID as a source of truth for creating the short URL of the long URL, hence that ID needs to be kind of unique all the time. That thing you will have to handle on from your own side. The remaining things are gonna be handled automatically. You don't really need to worry about it. Okay, this is done, and then we started working on designing a notification system. When it comes to designing a notification system, So we have to just simply use Kafka over here. Notification system is nothing but using notification services that are just simply used for sending the notifications, and then using Kafka mainly to just simply push the request in the queue, and then the workers are gonna be resolving them. We have even talked about messaging queue in PubSub model over here. Let's talk about caching over here. Even in caching we have algorithms, and we are just simply gonna be talking about them. So when it comes to caching, so caching is nothing but a layer that it stands between server and databases. So whenever you make a request, so instead of going request hitting the request directly database, instead of hitting the database directly, you are going to be just simply checking the cache whether there is some data in the cache or not. If there is some data in the cache, you will be getting that. Otherwise you will simply make a request to the database, then you will cache it, and then you will send it back to the server. And especially in the cache, there are temporary first of all, this is a temporary storage, and whatever you save inside this particular cache, there is a fixed timing that okay, this is the time to live for this particular data, and there is the fixed storage as well. It's not like it has a lot of storage. Suppose max to max it has, ultimately it can be anything. If the storage can be 1 GB around, and as for the storages of the databases, that can be immense, right? It can be 2000 terabyte as well. Okay, never mind. So types of cache, so there is a CDN cache, use static resources. So again, everyone knows about it. We use CDN for caching the static pages and all. Load balancers, web pages. So load balancers, they also cache the web pages on their own side. Server side caching, Redis is used for that, and proxy is also used caching. So we just know about all these things briefly, and especially when it comes to distributing them. So the best way to simply distribute a cache is gonna be consistent hashing. We have already talked about this particular thing in the in the database sharding section. So the thing is that this is one of the techniques to just simply to scale the database, and this is one of the best ones that simply resolves everything. And as for a real practical implementation of all the things that we are discussing over here, that can only happen when you just go through HLD section, low level design, and I am waiting for that. But again, that cannot happen just at once. We have to just simply go through the DSA part, because in low level design DSA is used. Honestly, I'm not good at that at all, hence I'm gonna be starting it from tomorrow onwards. Sort of I've started it. I mean, I've learned the languages, so I know Java, C++. So we are gonna be learning it in both the languages. Why? I mean, I want to learn the DSA as well as the two languages, Java and C++. Since and the good thing would be, if I'm solving one question in two languages, so it's gonna be sort of a revision. Okay, so let's see how it's gonna be going on. I will definitely solve it in two languages, Java and C++, so that I know I ended up learning both the languages plus the DSA plus good revision stuff. What could be better than that? Okay, never mind, let's continue. So cache data, cache aside, there are some other techniques over here. So these are the techniques that I was just simply talking about. So when it comes to cache here, so there are some techniques over here. The first technique is gonna be cache aside technique. What can I name it? Cache aside, cat hatao. First one is cache aside technique. So this is the first one. So what exactly we do over here? Cache aside technique is pretty simple. Keep the cache aside. The simply means hit the cache first of all. I mean, it's pretty simple. Cache aside technique in the sense, and this is for reading only. So let's keep this is mainly for retrieving. So cache and cache for retrieving. So whenever you are retrieving the data, at that time these things are gonna be used. So whenever we are retrieving, so we may use this particular technique, cache aside technique. That simply means first of all you have to make a request to the database. Sorry, caching. Yeah. So if cache hits, that simply means you get the data here. So that's okay. Return the data. If cache miss happens, that simply means you do not have the data in the cache. So you are gonna be making a request to the database. Database simply will give you the information. That information you will be just simply caching, and then you will be returning to the server. So this is it. This is how it just simply goes on. So cache, if a found cache hit, so when it comes to this, so you will have to check the cache. You check the, again, forget about the spellings, they're wrong, or some of the spellings are wrong, miswritten, but okay. If found cache hit, return the data. If not cache miss, fetch the data from the database, put it in the cache. Simple to implement DB, Docker structure cache can be different. For every new data, there will be always cache miss preheating. What is preheating? Preheating in the sense, look, whenever you start your cache for the first time, whenever you start your database, again there's gonna be data in the database. But as you started your server, as you started your cache, so whenever you get a request in the server, there's gonna be, by default there's gonna be no data in the cache, right? So even if you have started your cache, by default there is no data. So whenever you make a request to this cache data for the first time, it's gonna be empty, like there's gonna be nothing. So cache miss will happen. To resolve this, you can preheat it. Preheat in the sense, you will pre-save the most commonly used data in the cache, and that is it, the job will be done. I hope it does make sense. So this is one of the things. And through read through, this is actually another one. So we have read through cache data retrieval. So this is the first one, so let me name it 1. And the second one is gonna be, first one is the cache aside technique, we've already talked about it. Second one is read through cache. It's pretty simple. Read through cache in the sense, instead of like here what you did, you made a request to the cache, then if you cache miss happened, then you made a request to the database. Here what you are doing, you are making a request to the cache. If cache it, you will get the response. If there is cache miss, that simply means you did not find any data in the cache. Cache will have the responsibility of making the request to the database, and then database will return the data from the database side to the cache. Cache will preserve that, cache will save it on its own side, and then simply give you the response. So what happens over here, that you do not make a request to the database directly, rather you make a request to the cache. Cache handles everything. If it doesn't have the data, it makes a request to the database, gets the data, and simply sends the response back. Pretty simple. Let's talk about writing thing over here. So writing. So we've been retrieving the data. Now we are going to be writing. When it comes to writing, so there is something called write through. Again, we will be just simply going through. These are nothing but write through cache algorithms or wage. Okay, so as for this one, let's simply go through this. So read through cache. If found cache, it return the data. Cache miss, cache internal library will automatically fetch the data from the DB and put it in cache and return to the server. Pretty simple. Client don't need to bother about the DB logic and all. The cons is only that you are handling two things here at the same time, like handling the cache and the database. Hence, it's gonna be time-consuming process. So cache doc structure should be the same as database. First of all, this thing, that the database structure in this particular section, you could have changed the database structure. Okay, but in this particular case, you cannot really change that, because again, cache is actually handling the DB call and all, and then again you will have to preheat, and in starting that's gonna be cache miss, and apart from this particular thing, it's gonna take time. Okay, then we have a write through cache. Write through cache in the sense, it's all about gonna be writing. So what happens that whenever you wanna write something in the cache, so you write in the cache and DB at the same time. So ultimately, some kind of transaction is being used. I mean, in every database there are transactions. So whenever you are simply saving in cache and database at database, so save them in the cache and database at the same time, so using a transaction. So if it is saved in the cache, that should be saved in the database. If it fails being saved in the database, it should be removed from the cache as well. So ultimately, some kind of transaction is actually being used, going to be used over here. So we are gonna be using transaction. So ultimately, we are gonna be using transaction over here, and we are mainly using transaction over here so that we are sure that the data is actually saved in the cache as well as in the DB the right way. And if the transaction fails, ultimately the data will be removed from both. And apart from this particular thing, the pros is that data consistency is gonna be there. The second thing is it's gonna be slow, because we are taking care of two things, caching and database at the same time. So no doubt it's gonna be slow. So the second way is that use write back or behind cache. So ultimately, what it does is pretty simple. Back or behind in the sense of, you just simply save it in the database, and you just simply save it in the cache, and write into cache, and async write to DB. So asynchronously the data is going to be saved in the database. Pretty simple. So we mainly focus on writing it in the cache, and asynchronously we make DB calls from our side. So it is gonna be asynchronously saved in the database. The only thing is that it can be inconsistent. We saved it in the cache, but in the database it could have been failed, or it could have been some time-consuming task. Hence, the data inconsistency is gonna be there. Lastly, we have write around technique. So what it does, that In this particular thing, you just simply save it in the database, and whenever you save the new data in the database, you invalidate the cache. Okay, so what happens over here, that directly save it in the database, you are gonna be invalidating that cache. So whenever you are gonna be making a request, if cache is invalidated, it will make a request to the database. It's pretty simple. Invalidating in the sense, suppose by default you will have some data in the cache, okay, and as soon as you change some data in the database, so the cache that you have that got dirty, that in the sense that got that is not current data in the cache, hence you will invalidate that. That simply means whenever you are going to be making a next request to the cache, as the data is going to be dirty, invalidated, it will make a request to the database. You just simply get the result and will simply cache it. Without using 2PL, it can maintain the consistency. Ultimately, without just simply sending two requests, it can just simply 2PL means what? I don't know. Okay, never mind. So ultimately, what happens here? Without handling two things at the same time, it can still maintain the consistency. So this is how it just simply goes on. Then there is something called cache eviction policies, limited storage. This is one of the things. Let's talk about the other one. Cache eviction policies. So what are these policies? It's pretty simple. Cache eviction policies in the sense, it's not like your cache is gonna be empty all the time. Like there are gonna be times when your cache is completely full. So at that time, how you will be removing the data from the cache and storing the new things? At that time, this particular thing comes in the picture. And for this thing, let me use this color here. So first of all, we have, because we have limited storage, right? So we have limited storage and we have time to live as well. So how to and what to remove data from the cache, because we have to add in the cache, that is right, but the old data needs to be removed. So how we are going to be doing that? So first of all, the first one that we have, that is LRU, that is LRU cache. That simply means least recently used. Least recently used in the sense, any data, any kind of any caching data that has been used the least in the recent time, remove that. Pretty simple. And then MRU, it is hardly used, because MRU cache means most recently used, and we don't really remove the data that is being used the most in the recent time. Okay, and lastly we have not lastly, actually we have LFU. That's LFU cache. That means least frequently used. So what we'll do over here, when it comes to this one, least frequently used, we are going to be maintaining the frequency of the data that is being used. So if that is being used that is not being used a lot, hence we are going to be just simply removing that. Lastly we have FIFO over here. That simply means first in first out. So whatever data we got first, we are going to be removing that first. So first in and first out, this is one of them. And lastly we have random in the sense the data may be removed randomly as well. So this is also one of the things that you can do. So we talked about these things. Again, I'm not going to be going through it. Ultimately what we are doing, LRU, we are just simply removing the least used one, and here we are removing the most used one. Here we are taking care of the consistency, frequency. So whichever data has less frequency, that's going to be removed. And FIFO, first in first out, we already know. Random cache eviction, and we are going to be just simply removing the random cache eviction as well. That simply means we are going to be removing the data randomly as well. I mean, this is also one of the ways. Okay, so this is the this is one of the things. And apart from this particular thing, whenever, what is this now, whenever you just simply save something in the database, so at that time you may have the auth token. Ultimately these types of things you may be storing in the release, right? You may be storing the auth token, user ID, session ID and all, and they are going to be time bounded in the sense that's going to be time to live as well. And so ultimately if there's a key, suppose we are storing the username, the values, the key is the username, values the Aditya, again that can be anything, and time to live is the cache specific ready. So you can just simply mention the timing over here, that's going to be removed. And lastly we have load balancer, CD and dynamic caching also supported. So CDN support dynamic caching, API gateway they also support caching, proxies, server side caching. So these types of cachings they happen. Client side caching that actually happens in the cookies. We just save the information in the cookies. And the last thing that we have to discuss, that is the authentication and authorization. So just a minute, let me just simply crop this because we are not really going through that thing right here. So this has been all about caching, and then we have few more things like 10, 11, 12, three more things that we have to go through here. Okay, let me crop it here. So it is cropped, right? I hope so. And lastly, I have to just simply get a PNG of this. This is the summary. So copy to clipboard as PNG. That's done, and let's simply paste it here. So hopefully it's gonna be done. So this caching related thing we have already gone through. I'm not sure whether it's gonna be actually saved over here, so I better wait. Okay, that's done. So let's simply remove it from here. So this is nothing but the I can say what, the summary of the whole thing that we have gone through. And once we have gone through this, then authentication and authorization, autocomplete engine, and design Instagram feeder. So these are the few things that we still have to go through. It's already been half an hour, right? And I do not have good internet connectivity. Let's go through this last thing. I'm gonna be going through authentication and authorization right here, and these two things are gonna be discussed in the evenings. Okay. So without any further delay, let's simply get going and get it done. So coming back to this one, authentication and authorization. So we have a client. Again, it's pretty simple. The client will just simply you have to take care of authentication and authorization. Client will just simply send the request to the application. You need to authenticate the user, sign up, login, and all these things you must be knowing. Authenticate, who are you? Authentication just simply takes care of your identity, exactly who are you. And when it comes to authorization, so what you can do, access controls and all, access policies. I mean, access control and access policies, they are different ones. We have authorization that simply decides what you are actually what you can actually do on the application. As for the access control and access policies, they are the policies on the user level. So on the basis of a particular on user level, what a user can actually do, a specific user, what he or she can do. Okay, we are gonna be going through this. So it's pretty simple. This is just simply a client and server architecture. Authentication, login, username and password, we are gonna be logging it with it. Authorization, access rights, that's fine. Requirements, so ultimately these are some of the requirements. I mean, I don't even know whether I have to go through this particular section because it's really easy. Okay, it's not able to load it, that's another case. Let's simply go through it right now. So when it comes to the requirements, so user registration, sign up, allow users to register by providing necessary information, login, authenticate users based on their credentials. If you have ever built even a single database, server database, not database server, backend server, so you must be knowing about all these things. We may have multi-factor authentication, FMA. There are two things: single-factor authentication, 1FA, and one-factor authentication and multi-factor authentication. We will be talking about this. Implement a robust MFA. Password recovery, provide a secure process for users to recover their password. Session management, efficiently manage sessions of the users to ensure security. In a stateless architecture, we need to manage sessions of the users as well. Stateless, ultimately you are not saving anything. We will be going through it, especially we use tokens over there. And access control, to manage users roles, admin users, etc., to see what they can actually do. So this is mainly for the authorization part. As for the back of the envelope calculation, that can be anything. Suppose you are getting 100k users per day, so on the basis of per second you are going to be getting this many requests. Calculation is easy, we don't really need to worry about it. And apart from this particular thing, if you are actually estimating it for 5 years, so we would need to store the details of the users of the authentication and authorization, that is right. And suppose one user needs 5 KB space, so these many users we have in a day, 100k, so these are the 100k users, multiplied by 360 multiplied by 5, that simply means 5 years, multiplied by 2 to the power 10 multiplied by 5, this is actually equals to 5 KB. So 5 KB means 5 multiplied by 2 to the power 10. KB stands for 2 to the power 10. That simply means 1000 what 1000 KB 2 to the power 10. That's right. Not 2 to the power 10 means 1000 bytes, if I'm not wrong. Yeah, 1000 bytes. 1000 bytes equal to what? I think KB. I think bytes are equals to KB. Okay, again this is gonna be time taking, so let's not worry about that. Continue with this. Again, you can just do the calculation, and this much we are gonna be getting over here. Always try to convert it to the 2 to the power format, so the calculation gets easier. So what will happen? We will have different services for different things. Suppose we are working on Instagram, so we will have the authentication server. We will have our Instagram main server here. We will just simply send the request to the authentication server. Authentication server will just simply say saving the information in the auth database. It's gonna be one factor authentication. Multi-factor authentication in the sense you are making a request to the database. Now you are making a request to the authentication server. Now that authentication server is using some kind of notification server to just simply send you some kind of notification, suppose probably link for the verification or the OTP to just simply authenticate yourself. So this is called multiple authentication over here. So we made a request to the authentication. It is just simply you sent a request to the notification server. Notification server used its on things. So in the notification server you have Kafka, you have queues, you have publishers, ultimately subscribers, and you have particular services that just simply used for sending the request. And then you are going to be not sending the notification. Ultimately you are going to be sending the notification, then you are going to be validating. Pretty simple. Session management, there are two types of sessions, stateless and stateful. Stateless in the sense, suppose these are the two servers you have and you are not maintaining the data in those. I think this is also stateful if I'm not wrong. Let me ask this. Even if it has been mentioned in the class, I'm not quite satisfied with this. So if I am storing the data auth or session data in a shared DB so that multiple servers can use the session info, is it stateless or state? I think it is still stateful, but let's see. Probably, I mean, it could be this has been mentioned in the class, so it could be right as well. Okay, let's see. I do not have good network connectivity right now. That's interesting. Okay, so even though you are using a shared database, the key point is the session data is stored on the server side DB part of the backend. That means server remembers user session. Every request depends on the stored session. It is stateful. So what changes with shared DB? When you store session in the shared DB, multiple servers can read the same data, but this scaling it does not make it stateless. That's right. It is still not stateless. So don't take it like that. Rather, this is still gonna be, it's still stateful. So this is something that you have to take care of. This is wrong here. Again, it's pretty simple. If you are storing the data somewhere, so that's gonna be stateful. Especially when you are using keys and all, so that's gonna be stateless. So no session is stored, all info is saved in like JWT tokens, so that's gonna be stateless. Again, it's gonna be time taking. So let me make it red, bold, probably red as well. And okay, never mind. This is how it's gonna be going on. This is still stateful because we are of course saving the data in the database. Okay, and then when it comes to stateless, so when token based authentication is mainly gonna be stateless over here. And there are two types of authentication, session based on session IDs, ultimately session authentication, session based authentication, and token based authentication. And we are going to be just simply sending the request. That's fine. Session connection, DB table, session table. Ultimately, when you are working with session based authentication, so a session is going to be generated. That session you may store it in the server itself, or you may store in the a particular database. So that session is going to be stored, and a session ID will be sent to will be saved on the client side in cookies. And whenever you make a request, that session ID will be sent to with the request. On the basis of that particular session ID, your server will find the session and then it will authenticate. So this is how it just simply goes on. Token based authentication, very simple. JWT is going to be used, so we are not going to be talking about this. And there are two types of things: access token and refresh token. So when it comes to this, so ultimately, whenever you are authenticating yourself, so you are going to be generating two tokens: access token and refresh token. And now, with every request, you are going to be sending the access token with you, and on the basis of if access token is not expired, you are going to be allowed. If the access token is expired, you will have to send the refresh token from your own side. If refresh token is still valid, that simply means refresh token will be used for generating the new access and refresh tokens. If refresh token expired, then okay, you are gone. I mean, of course, you will have to sign in again. And as for the flow, so we just simply generate the access token and refresh token, and we just simply send the access token and refresh token to the client side, and then client just simply keeps sending them, okay, depending on the need. And let me see, I think we restore the refresh token on the client side, database side as well. So tell me the flow of access token, show me the flow of access token and refresh token. So let's simply go through the flow of it. And if we actually just go from here, so every request after authentication will come with the access token. Now our application will decrypt blah blah blah. Of course, you will have to check whether that token is still valid or not. Checks of the TTL, time to leave of access token. If not expired, application server will check user permission. Then user is allowed. That is right. Refresh token, it is mainly used for generating the access token. Access token will have a short time live time. Refresh token will have long live time. And every request after authentication will come with the access token. Now our application will decrypt the token using its own secret key. Of course, JWT secret key if you are using JWT over here. Checks the TTL of the access token. If access token is expired, user will generate a new token, and ultimately refresh token is going to be used over there. Full flow access token and refresh token. So user sends email plus password to the server. Server verifies credentials. Server generates access token short life, for example 15 minutes. A refresh token long life 7 days. Server sends back access token front end, memory, local storage. Refresh token usually in HTTP cookies. So access token you can store anywhere, it doesn't really matter. Refresh token you will definitely need to store on the in the cookies, HTTP cookies, so that they are just simply sent with the HTTP requests and all. First of all, this thing. The second thing is that you have to send access token in every request, and refresh token is gonna be sent only when your access token is expired. So but both the tokens need to be saved on the client side because you need them sometime or the other. So this is the first thing. Then front end sends a request with the authorization bearer access token. So you will simply send the request. Server verifies the token. If valid, returns the data. Access token expires. Access token is short-lived. After expiry, save 401. I mean, it will return if that is expired. At that time, front end sends a request to / refresh token. Browser automatically sends a request to the cookie. Browser automatically sends refresh token to the cookie. Server verifies what? Yeah, that's right. So server verifies refresh token. If valid, generates a new access token. Server sends new access token. This is just simply goes on. Retry original request. Front end retries API code. I mean, this is pretty simple. What happens that whenever you authenticate yourself, you just simply generate your access token and refresh token. You send it to the client side. Client stores it on the cookies. In cookies mainly. Just let's. And once that is saved, then in every request you are going to be sending the access token. If that gets expired, you are an automatic request. It's not like you will have to send the request for the refresh token separately. You will have to write your logic in such a way so that once you got to 401 as a response, that simply means it is expired, access token is expired. So just after that you have to write the logic for sending the request, for refreshing the token with the refresh token, and then you have to write the logic for retrying your original logic. So this logic again we can ask ChatGPT to generate it right here, but you can write it on your own as well. It's pretty simple. Okay, so this is the thing that we have gone through. Why do we need two tokens over here? Access token, refresh token, pretty simple. Gmail, web browser, and this is pretty simple. In login, Gmail, web browser. So ultimately, whenever you are logging with Gmail, this is just an example, so let's forget about that. So forget be it Gmail or be it any other application. If your access token gets expired, so you will have to send the refresh token. Okay, that is just an example, so I'm not going through that. How password are stored in the database? You can directly store the password. You can hash the password. Depends on exactly what you are gonna be using. And what is the rainbow table? This is sort of an attack technique. So rainbow table in the sense there are gonna be multiple huge sets of passwords saved in the database. Now with the help of that you will try to crack the password of a particular user. So that is a huge data set of commonly used passwords. This is that. Using permutations and combination, you will try to just simply guess the password, nothing else. Three-way store password set. Three-way to store a password. This is something interesting. To save your password secure, you may use a salt paper technique. Salt paper technique in the sense you have your main password. You will be just simply hashing it, and you will not hash it directly. You will hash it using the salt, some gibberish, some extra strings, and some paper in the sense this is also some string, but this is more secured one, and by adding both of them, you are just simply gonna be hashing the password. Hence, it will be hard for anyone to just simply guess it. And apart from this particular thing, in salt and right, here it is. I hope I'm audible right now. Am I not? Okay, it turns out okay, I'm audible. So tell me about salt and paper technique, how they are used, and do we actually store salt in our database? And if I'm actually hashing the password, so whenever I am, just a minute, I forgot my own question. Okay, so suppose I hash the password, and the next time onwards I'm gonna be hashing it again. So okay, so tell me about salt and paper method, how it actually works when hashing the password. And whenever I'm hashing the password using salt and paper, so ultimately I'm using some strings. How are those strings are determined? How do we decide this string is going to be used for hashing? And are those strings same all the time, or they just simply keep changing as like the salting value and the paper value and all? Tell me about everything. Okay, let's know more about it. I had a bit confusion here, so it's better to just simply know more about it. And good hash functions are the ones that just simply take time. So there are multiple functions. There are SHA-1, SHA-256, MD5. These are the functions. These are the basic functions. And there are some functions called argon, to bkit, and script. So ultimately, the good function can be the good hash function can be that takes time, because especially when we are hashing, we want our function to take time, so that a hacker cannot just simply get the computation done really quickly. So that is why we want our algorithms to take time. And apart from this particular thing, we have authorization, we have role-based authorization, policy-based authorization, access control list. Role-based authorization, pretty simple. On the basis of the role, you will be just simply getting the job done. Policy-based authorization, that simply means you will have some policies over here. Policies in the sense, you can have some users can access paid questions, no more 3 requests, but ultimately policies in the sense there are going to be some values in your database, key value pairs. If you are using MongoDB, so there are going to be some key value pairs, and they will just simply say that whether suppose few users bought the course, few users did not. So the users who bought the course, they are going to be accessible for the course. They will be allowed to view the course, others are not going to be. So role based authentication, in the sense, a role it is mainly used it is mainly categorized in 3 things: admin, member, and order. There can be many categories as well, and you just simply decide which particular role should be able to which particular page. So this is sort of on the page level. And policy means, on the basis of some internal values that you have, on the basis of those things, you are going to be deciding whether it is actually allowed, authorized to just simply get the course or not, something like this. Because if you are a user, so we cannot create 2 roles, for a paid user and for a non-paid user. Hence we have to create policies over there. And lastly, we have access control list. It will just simply, it is highly granular control. That simply means for a specific user, you can determine what all this user should be able to access, and hence this will be used for that. So we have already gone through it, and there are some API endpoints for signing up, for logging out. So we can just simply go ahead with this, and let's simply go through it now. So over here, your salt is what is salt in password hashing? Salt, a random string added to the password before hashing, that is right. So this is the password, this is the salt. So whenever we are just simply passing it to the hash function, so password plus salt. Why do we use salt? Without salt hash, same output for everyone, that is right. Attackers can use rainbow tables, pre-compute hashes, that is right. When we are using this, so there are gonna be different hashes every time, hence the result is gonna be different. Even same password, different hashes. Important point: salt is randomly generated, different for each user, stored in DB alongside with the hash. So whatever hash we get, the salt is also stored in the DB. That is right. Great job. So we do store it in the database. So paper, a secret string added to the password like salt, but with a bigger difference. Stored in DB, yes. A paper, no. What is this? What have I done here? Never mind, something just happened, the whole color changed, but okay, forget about that. So important randomly generated, not this. Same for users, will not be saved in the database. Salt, same for all users. Salt is not gonna be same for all users. Paper is gonna be same for all users. Secret, not a secret, but this is gonna be a secret. That's right. So we have password, we have salt, we have paper, and then we are just simply gonna be combining all of them. We are gonna be hashing them. So what is paper? Uh, where is paper stored? Environment variables or in server configure process.env.paper. That is fine. Your main question: how are these things sorted paper determined? So salt, how is it generated? Automatically generated using secure function. So crypto random bytes 16 to hex. So ultimately it is generated like this. Library like bcrypt automatically generates salt, so you don't decide manually. System generates random salt every time. So this is done. Paper, you decide it. So we decide the paper long random secret JWT secret API secret. That's right. So do these valuable changes. Salt changes for every user, changes for every password hash. Changes for every user, changes for every password hash. Salt just simply keeps changing. Paper usually same for all users. Okay, that's fine as well. Full flow. So user sign up, we have salt, paper, all these things, hash, password, all these things stored in DB. So hash plus salt, these two things are actually stored in the database. So we have to take care of this thing. And when input a password plus, whenever we are trying to log in, so at the time we just simply get the input password plus stored salt plus paper and hash it again. So whenever we are actually trying to log in, at that time we get all these values from the backend side, from the database side, and we just simply hash it again. So ultimately we do make our DB call and then compare it. Okay, this is how just simply goes on. Understood? Alrighty, so this way just simply gets done. Not really, not that easy. So we would talk about all these things, and similarly we have create, grant, revoke, expire, validate. These are nothing but the APIs that are gonna be used. We are definitely gonna be storing the salt as well on the on the database side. There are libraries called bcrypt and argon2 that just simply get the job done. User registration, this is the overall flow over here. So user just simply sends a request and just simply database stores the information. When it comes to login, so we simply send a request to the our server. Access token and refresh tokens are generated, and that is it. And when it comes to session management, so ultimately with each request we are gonna be sending the access token. If it expires, we are gonna be sending the refresh token. Pretty simple. And this is understandable. Client DNS load balancing, there can be rate limiting implemented here. There are algorithms of the rate limiting as well. There's web tier, DB tier, notification tier, so there can be different tiers. Logout user, you are gonna be just simply removing the token from the, if that is a session based authentication, at that time you have to remove the session. And if that is a token based authentication, so you are gonna be just simply invalidating the, you cannot really invalidate the token, rather you can you can remove the token from the page on the client side. And when it comes to auth 2, so auth 2.0, so ultimately here you use something called sign in with Google, sign up with Google. So you just simply use these services, and ultimately when you click on sign up with Google and all, so Google just simply sends you the access key, and on the basis of access key you are actually able to authenticate yourself. So this is how this simply goes on. Alrighty, so this much we have already gone through. Just a minute. Okay, so this is the thing that we have already gone through, and lastly we have few more things remaining. First of all, R2complete engine. This is sort of the engine that we are going to be working on. Again, this is going to be high level architecture, high level design, and then designing the Instagram feed, how it works. These two things are remaining that we are going to be going through like after half an hour or something, or probably one. And this way we are just simply going to be getting it done. And once this is done, we will start working on the DSA part. Really good stuff. Again, it's not like these are the only things. We actually have to go through the 3 to 4 things right here. So we are even going through this particular section. Web dev project, there was one, and there are some things related to cohort, mainly this v-test. This is nothing but checking the logic. So whatever, v-test is mainly used for checking whether your APIs of your backend are working well or not. And I was just simply learning about this, and this is not difficult one, it is easy, so we don't really need to worry about it. I will definitely go through this very soon, in which I'm gonna be talking about v-test. It is just like jest. So, and overall v-test directly supports all the functionalities of jest, so you don't really need to worry about it. We will be just simply talking about it. It is nothing but testing your APIs. So you will write the code for checking your code. It's just gonna be like that. Okay, all these things are gonna be discussed very soon. Until then, bye bye, take care. Again, in the previous days it's been pretty hard for me because there's been many things going on. There has been some many marriage ceremonies and all, and it turns out that I totally got out of track. That doesn't mean I haven't been learning, but it has been quite hard for me to just simply go live. But from now onwards, at least I'm gonna be going live once a day, or it can be many times a day as well. Never mind, I'm gonna be catching up soon. Until then, bye bye, take care, and see you.